that. So, Ashil.
Is the mic working? Because I don't know if we've used this one already. Yeah, all good. Okay. Hello, everybody. I'm going to give you guys a bit of an intro to myself if I step onto this side so I don't get blinded. This is my first time here, hopefully not the last, depending on how this goes. Well, I guess we'll judge it together. Just a bit of background about myself. So I came to the UK in 2016. I grew up in Belgium originally. I'm not a developer, so my background is, so I studied physics, did my BSc and my master's at Imperial. So I've worked in various different sort of roles in the data space, particularly around data science, machine learning, optimizations, and recently sort of converted into a bit more of a developer role as well, with the whole AI craze and LLMs being able to translate from one language to another. I actually met Josh at work. We met about a year and a half ago now, I think. And a lot of what I do at work is actually programming in C# these days. So if that serves as testament to or as an invitation to try other programming languages that you might not have sort of wanted to dabble in the past, use me as an example, I guess. So after university, I spent some time as a data science researcher at Imperial as well, then moved on to a startup, a spin-out we did from the college. That lasted for about 2 years. And then, over to the dark side, consultant for private equity funds and their portfolio companies on all things data, so data warehousing, cloud, data science initiatives, again, optimizations. Worked very closely with technical teams on that, more on the developer side of things as well. So started getting a bit more exposure to full stack and sort of cloud solutions, which, believe it or not, academia doesn't really teach you much about. And then, now I've been at this company called Health Partners. We're a leading UK healthcare company in the occupational health space. And I'm a data scientist and AI engineer. When I started, it was just me, and now we're growing the team to about 8, so must have done something right. But the talk I want to give today is a bit different, so I don't really want to delve too much into the code itself, because I feel like you guys all know how to program otherwise, or have a various degrees of experience, but at least know the fundamentals. So it's probably not as interesting to you if I show you yet another way of constructing an agent and adding instructions and attaching a tool to it. So my talk today is going to focus a bit more on when AI agents, or particularly LLMs, aren't fit for purpose, and what do we do then? Because a lot of the time you might be faced with a business stakeholder or a situation where someone wants you to build this new fancy, AI agentic system that can do whatever recommendations and filter data, segment customers, and you might get to a point where your results are not super good, and what do you do then? So the example I'll go through today is hopefully going to evangelize you guys as to not using, or rather to not use LLMs to inspect, analyze, and generate recommendations based on tabular data, so numbers, basically. So LLMs are not trained traditionally to deal with numbers, and we'll see, hopefully, very quickly, how badly they perform compared to something super cheap, super easy to build. So I've built this little Streamlit app that is now decided to not run, so great. So, this is the business problem we're faced. We're faced with a customer churn prediction problem. So let's assume that you're a company that receives tickets or emails from your customers, could be complaints, could be praise, you don't know what they are, and you're tasked by senior management to build some sort of system that can make sure customer retention is high, particularly for the telecommunications industry, is the data set that we're going to work with today, where customer churn is very expensive, and most telecom companies lose 15 to 25% of the customers every year. As you might know, keeping a customer is a lot cheaper than acquiring a new customer, so you're actually, as a business, very much incentivized to spend a bit more money, potentially through discounts, to retain your customers. So this company, call it Telco Company 1, has got a data set, like most companies do, about the customer. So what kind of subscription they're on, how much they spend per year, how long that subscription will last, etc., etc. Most of it is it's stored in Excel or CSV or some sort of SQL database. It's mostly numbers, and it doesn't really have much qualitative information in there. So what's wrong with pure machine learning on that? Number one, if you get a ticket coming into your system or some sort of customer message, how do you go from that to something that you can do some sort of ML on? When do you, to try and calculate what the risk of that customer is of churning? More importantly, how do you know if the query that's coming in is even negative, for example, or is something that even should necessitate something like a churn prediction model to be triggered? So what we're going to hopefully get to the bottom of today is why a combined system, so an agentic system, but that has traditional machine learning models, in this particular context, binary classifiers, excel, because you're basically leveraging your agent to deal with the request, the text information, and then decide through tools, which we've just described, that become machine learning models in themselves that you curate and build and can serve through MCP or whatever other technology you might like to use, excel at this task. So what I've done, well, if I scroll through, what we can see is in this particular problem, we're going to get some sort of natural language query that is coming in. We're going to need some sort of contextual reasoning, which is what reasoning models are good at. So, you know, define in this case, we've broken it down to there's a technical issue, there's a pricing complaint, or there's a or it's just a loyal customer, someone giving praise, and we don't really need to action anything because they're low risk of leaving. This is something machine learning can't do very well. Traditionally, we'd have to go down the route of NLP, trying to break that down, trying to generate some sort of vector or embedding, the traditional sense, and then decide how we classify that into some sort of bins or buckets, which is something that we can now just leave to the agent. The agent just decides, based on what's coming in, what it needs to trigger. We just give them all these ML models as tools, essentially, and it can decide when it needs to trigger it and what kind of action needs to occur off the back of that. Also, traditional LLMs, well, not traditional, LLMs, have the added advantage of communication and empathy. They can also then instantly translate those results into something that can be sent back to the user and hopefully get them to be happy with the response and stay on as a customer. So in this example, we might go through a few of the code examples later, but I really want to emphasize that it really doesn't matter what language you code this in. The backend for this is using vanilla GPT. We don't even need a framework. A lot of these big players in their APIs have tool execution parameters in their API calls. So you can literally, with JSON, is all we've done here, define what our tools are. Our logic, in this case, is hosted in the same backend in the server. That's where the functions get triggered. But that can be an MCP. That can be which is hosted in a serverless application, like the one Samson was talking about, that only gets triggered on consumption. So again, can be really done quite cheaply and very neatly. So perfect combination, intelligent agents, something that can do both the calculation essentially through our ML models, but also can interact with our customers and perform all of the reasoning. There's a huge business impact here as well. If we were to just leave our LLM to perform the churn prediction calculation and give us some sort of probability outcome, if that probability outcome is over or underestimated, that can lead to additional, well, ideally if it's underestimated, always, that would actually make things cheaper, but you wouldn't retain as many customers, so then you would lose money on the back of it. But if it consistently overestimates the probability of a customer leaving, we might be issuing way too many discounts if we have some sort of tier discount system, which leads to a lot of leaked revenue, or rather additional costs. So for this one, we've defined, for this particular example, a unified discount policy. Let's say that depending on the risk level of the customer, we're happy to issue a specific discount. Say our finance team has done the math on this, and this turns out to be profitable if run this way. So we have a duration for each of these discounts and a discount rate. A critical difference, as I was just highlighting, is that we could waste a lot more money if we had, these are actual numbers based on the example that I'll take you through in a second, where on a scale of 10,000 customers, we would have lost $870,000 additionally per year if we just leveraged OpenAI GPT to do all of our churn prediction for us. Oh, apologies, it's not big enough. I don't know if I can do. I mean, happy to zoom into sections later as well if there's questions. I think this is again, very much AI generated with my help, which will also be a testament to it. You could probably tell by all of the logos, but if we go through this, about 300 lines of code were enough to do all of this. We only have one simple agent loop. You can add whatever complexity you want on top of this. You can wrap this around, LangChain. If you're programming in Python, you can use Microsoft AI SDKs if you're doing a C#. Framework I really like is Mastra. Don't know if anyone's come across it. It's the TypeScript framework for anything AI. Highly recommended. Also very much allows for all of this stuff to happen. So just quick background on the ML model that we've actually trained, because I think it's important. So our data set consists of 7,000 total customers. We have 21 attributes, which are our features, and we just want to perform a binary classification task, i.e. customer will churn or they won't. So it's a binary outcome. Our features include stuff like demographics, the services we provide to them, phone, internet, streaming, how long they've been with us, the contract type of billing, and then our target variable, which will be your churn, yes or no. So for anybody who cares a bit about ML, so the normal steps still go into this process. I'm just trying to highlight that you can't really cut corners on this. AI will help you, but you still need to deal with your data like you would in a traditional data science problem. So engineer your features. You need to one-hot encode. So this is for features that are that you need categorical to turn into categorical variables. So that's variables that either where you're modeling the occurrence of something, yes or no. So for example, someone has a phone with us, yes or no, etc., because you can't just pass the word phone to a model and hope for it to understand, because it's not a number. The model architecture we're using here is what we call a voting classifier ensemble. So we use these three models: gradient boosting, logistic regression, and AdaBoost. And our final prediction is a weighted average of what these three models score. And that brings us up to 80% accuracy on our test set. So I really wanted to, again, we split our training and test set 80-20, which is pretty standard. The thing I really want to drill down on here is that I actually went through the trouble of spending my own money on trying to use GPT to actually classify the same examples that I used on the test set with the traditional classifier model. It cost me about $10 to do, and the accuracy was only 40% versus 80% with the actual model. So they are a lot worse at doing this. And as we can see here, this is the comparison I did: 44.9% accuracy, $12.63 spent, 31 minutes training versus about less than 1 second to actually train this model. 7,000 rows is not even that big. So, we can see that GPT-4 is even worse than randomly guessing if you break someone on this. So don't use it when you have lots of tabular data, because you're going to spend a lot of money, it's going to take you a lot of time, you're going to get a lot of errors, and you're going to be really unhappy. So hopefully, please listen to me. And the punchline is that, first of all, this is not a deep learning problem. A classifier will do normal sort of gradient boosting, random forest methods will do very well at this kind of data set size for this type of problem. And our ML model is the calculator. We want to really unlock the value of these intelligent systems by looking at the actual problem we have in front of us. Don't just throw AI at it and just say, okay, GPT-401, the newest, whatever, 01, the newest reasoning model is going to do amazingly well at this. No, it won't. It hasn't been trained to solve this particular type of problem. So actually look at what kind of data you have and decide what system should work best on it, and test it as well. And here we're going to go through a bit of a live demo. So I've picked 3 different examples of different risk levels for different costs. So 3 different customers with 3 different risk levels. We've got a high-risk customer, so our ML model rated this as 62.3% chance of churning, a medium risk 50.7%, and a low risk 10.5% problem. So here we'll see the customer profile. So this high-risk customer has been with us for only 1 month, being charged $36.45, month-to-month renewal contract. And our ML thinks, or our model thinks, this guy's going to churn. This person has written, I'm going to read it out loud because it's very small, doubt you guys can see it, but it says, I just signed up last month, but I'm already frustrated. The price is way higher than what I was quoted, and I keep getting charged for services I didn't ask for. This feels like a bait and switch. I'm canceling unless you fix this. So here, our loop, basically, our intelligent agent should, in theory, recognize that this is a pricing problem and should then invoke our churn prediction tool and then should issue a specific discount level based on the risk level of this customer. So we're just going to compare all 3 approaches. So if we just run the pure LLM loop, this is literally us asking the LLM to give us a probability or a risk for this person to leave and then therefore calculate a discount. So as we can see here, our LLM thinks 85% chance of churn, reasoning the customers express strong dissatisfaction, whatever, we can read through the whole text. So our LLM would have issued a 30% discount for 12 months, which would have cost us $131 basically, if we were to just use our AI or standard LLM for this. If we just run our pure ML, great, we have a probability, we have a prediction. What do we do with this? First of all, we would have had to figure out whether this is a pricing problem altogether, what kind of issue this is, how do we communicate this back to the customer now? We need to worry about standard email templating, loads of issues that we can fix by running our intelligent system where our LLM is going to hopefully discern what kind of problem it is, call the right tools, and issue the right discount. This might take a second. There you go. So now we can see here the tools it's called. It's run our predict churn risk. It's run our guest customer profile and get customer history. I'll show you where these are defined in the code later because it's just JSON instructions that you can pass onto the OpenAI API. And then it's drafted an entire agent response, which we won't go through reading right now, because it's quite long, but look, it's issued 25% discount only for 9 months at a cost of $82. So the difference is quite stark actually in what we would have had to spend. And the probability, as we've seen by actually running our LLM on our test set versus our ML model, of actually the LLM getting that probability of churning right is lower. So in fact, it's just hallucinating these probabilities. Oftentimes when you force a large language model to give you something back because you want that, if it's not capable of doing so correctly, it's still going to do what you've asked it to and try its best guess, when in fact it actually doesn't have the right tools or the right training to actually give you the answer you need. I'll share the repo with you guys. You can run it by yourselves, but let's pick the low risk one. I appreciate this is going to be quite evident now that we've run the first one. Coin still stands here. This is giving us a 25% probability of churning, so quite a bit lower. This person's just saying they've been a loyal customer for 6 years. They've always been happy with the service, but they just noticed that their bill went up. So again, we have a pricing issue here. I think the medium one was the technical issue one anyways. But yeah, I would have issued an 8% discount for 2 months, and we run our intelligent agent on the same input. So again, it's literally just a string of text, and then our agent will decide whether it should call the churn prediction tool, whether it should calculate a discount based on it. Hopefully it's run it again. Yes, it's called our predict churn risk tool again, alongside our get customer profile and history to draft a better response as well. Again, why tool calling is useful because it can gather all the additional context that might be needed. And then it's issued a 5% discount for 1 month, so we've saved money again by doing this. At scale, this is very powerful. I hope that point sort of has come across at this stage. The other thing I will note though is that oftentimes people will tell you, well, you're not using enough tools to solve your problem. I don't agree with that. Fundamentally, I think oftentimes you're just not using the right tools. I think giving agents less tools leads to better results than just giving agents too many tools. Why is that? We have something called tool fatigue, which is a documented problem where agents tend to not look at tools that are defined later down the line in the script. So they tend to focus on the ones that it's called positional bias, the ones that are at the beginning. Also reasoning models, when you are trying to build really complicated loops where a lot of accurate tool calling is needed, it only takes one of those to fail for your entire thing to go wrong. So maybe your model is doing things very in a very correct reasoning sort of chain, but it's only failing in one particular spot and it can sort of throw your entire system away. So again, a few powerful and correct tools can lead to much better results than a very complicated system where you might think you need to feed it all these additional context streams and new tools to solve a problem. I didn't think I would be done with this so quickly, if I'm going to be honest with you guys. I've talked very quickly. So maybe before I go into the code, I'm just going to see if I'm just going to pause here and just see what if there are any questions about any of this at this stage before I jump on to some of the repository maybe. Very good question. I'd say none of my job is traditional ML these days, barring maybe like 5% of it. So there are some projects, for example, we've been developing a pipeline to analyze different themes and topics from some of our admin emails inboxes. So we have a lot of requests that come in from customers that our admin team sort of deals with manually, and we want to see what those main issues are, those main streams. So what we did was we embedded all of the data. We then ran a clustering algorithm on it to try and basically see if the data clustered into different themes. Then we sampled those themes, and again, using an agent at that point, we basically try to discern a theme from those clusters. So we go down the math route to actually detect the separations in the data, and then we use LLMs again to, so we use LLMs to embed traditional ML, and then LLMs again to basically make sense of the clusters. So that's, again, I hope that speaks sort of to the power of these hybrid systems, especially in day-to-day use. But that, I would argue, is a relatively sort of small side project that I've done at work. My main emphasis really is on clinical productivity. So how do we get doctors, it's context engineering at the end of the day. How do you make sure that you grab the right information for the right patient from the right case, that it doesn't sort of leak to an area where it shouldn't, and that those responses are also grounded and validated. Citations need to appear, etc., especially when you're dealing with medical information, which would be quite sensitive. One of the things that we've played around quite a bit with as well is the use of GraphQL as a way of getting agents access to your database, essentially, without them running straight away sort of SQL queries or operations or mutations on your database. And that's quite neat, actually, because through the use of JWT tokens, you can actually restrict the permissions of the agents, and based on who is triggering the flow as well within a tool, within the whatever platform you're in. So it's a blend of things. I think the best place to be in these days is to be able to have sort of a working knowledge of, I'd say, AI and systems engineering, enough software development that you understand what a back end, a front end is, and how they should communicate, and a bit of sort of security principles. And then, but also read a bit about data science and statistics, because it'll help you understand which LLM to use for which task, because you understand what has gone into the training process of it, and what sort of the architecture is of a transformer, or how it works, and why it's good for specific problems and what isn't. And it'll also allow you to, these models are easy to build. AI is very good at helping you build a classifier, and you're probably going to get by just understanding what it is and when you should use it, not needing to know every single detail about it. So I guess from my own experience, it's proven really useful to have a foundation in all three of them, with my spike being on the data science side of things, so that if you're in a small team, you can still push things forward by knowing all three. But then if you get into a bigger team, you can easily collaborate with the experts in each domain, because also kind of what they're doing at that point. Data science, which three visual apps software do you have data science? Do you prefer to hire a data science, software engineer, or software engineer to do data science? I mean, I'm biased because I come from one specific area, so obviously I'm going to choose the same path that I sort of went through. But fundamentally, I know loads of people that did computer science at university, and they were never really exposed to this stuff, and then they pivoted and became some of the world's best quants, if you will. And then I have other friends that sort of started off more on the physics, big data analysis front, and are just full stack Java developers now. So I think actually it's just about sort of the will to learn these things, and I think it's also about finding the right setup for you, where you'll also get. I would hire someone, for the example you pick, I would hire a software engineer to also train them up in data science if I was in a company or a place that allowed for that. I think a lot of places you've got to be careful with. You're going to be boxed into what your title is, and there's going to be little room for you to actually explore and sort of push in other areas. So you're better off just doing your own thing or learning it first and then selling yourself as both. So that comes in as your sort of responsibility. Or find a place, there are also plenty, like the place I work at right now has given me the opportunity, for example, to write thousands of lines of .NET code, which is something I would have never been able to do if I hadn't gone to a place that had a bit more of that startup vibe. Let's build this team up from scratch. Do you teach your physics student on a curve? Can I teach a solid computer science student how to do physics? Well, none of this stuff works. If you take a lot of if you were to interview a lot of people that studied physics, I wouldn't even call them physicists anymore, 5, 6, 7 years after they finished, if they haven't sort of kept up to date, they're not even going to remember how to, do some partial total derivative of whatever system anymore. That stuff you lose, right? So it's all muscles. Like, I think anybody that tells you you can't learn something is just lying to you. You should say, no, it's all a muscle, right? It might take you a bit longer if you don't have the foundation, but I strongly believe that you can teach everybody sort of everything. And I think that especially if you apply the right method for the right person, and if they want to learn. Thanks for the three systems. How consistent are they in their response if you hit when you keep them flat? Let's give it a go. I mean,
explainability, because obviously people do no idea what they're doing, or maybe do. Is there which one would you prefer for explainability as well as consistency?
Okay, that's a very good question. Again, this is a demo I built literally in one afternoon, so it's going to have a lot of shortcomings, but there are great questions nonetheless. When it comes to general sort of LLM flows, you have telemetry built into like a lot of these frameworks now. You can use stuff like Brain Trust, Arise, or even Azure OpenAI. I think Foundry allows you to have observability built into it. So there you can see sort of the reasoning chains behind it, like how long it's spent on each problem, whether it's called a tool or not. I would definitely go down that route. But when it comes to traditional ML versus LLMs, LLMs are non-deterministic. These models are more deterministic, and they're actually rules and sort of numbers based. So which at a lower degree, so it's a lot easier for you to potentially do something like a feature importance like analysis, where we could take this classifier and look at from those 20 features that it's been trained on, which ones are the most determining for the result it's given for that prediction. So to a business stakeholder, non-technical audience, you going and saying, actually, and don't quote me on this, but whatever, like gender and age plays the biggest role in like someone churning, is a much better answer than our models consistently saying it does so, like without it, you actually being able to mathematically sort of show like how much it does so, basically. Don't know if that fully explains the question, but if we look at the, let's run this one again on the low risk one and see what probability the LLM comes up with now. What we know for sure is that a model like a binary classifier, if we run it on the same data points over and over and over again, it's going to give the same exact response every single time, whereas our LLM might not. So here it's done 35% reasoning. I can't remember what it suggested. 25, there you go. It's already hallucinated 10% more up and down. And the problem is that if we look at this, if we didn't know this was 10% and we go and read this, right? I've been a loyal customer, blah, blah, blah. I just noticed my bill went up by 10%. Can you help me understand what changed? And we look at this probability as humans. How do we judge this is wrong or right? Like we might, build validations build observability into it. Make it explain its reasoning. Like, sure, you can build all of the infrastructure around it, but you're still left with all these uncertainties. And the moment it starts diverging from the same answer over and over again, oftentimes, and I find myself in this situation as well at work, where I'm just like, well, sorry, it's like I lower the temperature to 0, so I try to enforce as much determinism as possible. New models don't even have that anymore. Context engineering, limiting the right inputs. There is that, as Samson was saying, there is a lot of sort of variance in this that is very hard to sort of capture. So these are great at summarization like problems. So when it comes, look at Claude Code, like you can build an entire sort of hierarchical file system of markdown files that allow these models to traverse this perfectly and grab the right information with citations, attach them, etc. Amazing for that kind of work. The moment you try to predict the price of Bitcoin or whatever, you're left with quite a big issue. The funniest thing about all of this, though, is that transformers, if trained on numerical data or using whatever mathematical concepts for their solvers or whatnot, can excel at numerical problems as well. So it's not that neural networks are not good at solving these kind of problems. It's just that the data we've given it and the rules we've taught it have nothing to do with the answer we're asking it from it. And when it comes to LLMs, obviously not if we just train our own neural network. Okay, appreciate we're almost at time. I honestly don't think there's much value in going through the code together or any of it. We'll push it up to the repository as well. Feel free to email me if anything is sort of not very clear. But again, it's beautifully simple. It doesn't even require and this is sort of the point, is that before you go into building using whatever library or whatever tool that it is you think you need, try to first break down the problem to sort of first principles, look at the data that's coming in, look at the answer you want, try it with some vanilla implementation with APIs, validate it first, and then build complexity up from there. Don't think that, more complex system equals better results, because it's definitely not true, at least from my experience. Thank you. Thanks very much.